H3PO2, H3PO3 and H3PO4 will neutralize X moles of NaOH, Y moles of calcium hydroxide and Z moles of aluminium hydroxide respectively. Assuming all as a strong electrolytes. Actually, oxide acids of phosphorus are weak acids, are in the ratio of. So, the ratio of number of moles required for the neutralization of 1 mole each of H3PO2, H3PO3 and H3PO4 by the NaOH, calcium hydroxide and aluminium hydroxide, X comma Y comma Z, and he is asking the ratio between X, Y and Z. Okay, so as we know here H3PO4 N factor is H3PO2 when treated with NaOH, it can form NaH2PO2 plus water. Okay, so here in this N factor is equal to only 1. So 1 mole of it requires 1 mole of NaOH. Okay, so as he has given X moles of NaOH, so I am writing here X is equal to 1. Now coming to H3PO3. H3PO3 basicity is 2. N factor is equal to 2, basicity 2. So when it is treated with the calcium hydroxide, it can form CaHPO3 plus 2 H2O molecules. It can able to give 2 H plus ions. Now here for 1 mole of this, how many moles of calcium hydroxide required? Only 1 mole as per the balanced reaction. So Y is equal to 1. Now coming to the H3PO4. H3PO4 where basicity is 3. When it is treated with aluminium hydroxide, it can form AlPO4 aluminium phosphate plus 3 moles of water. Here basicity is 3 for this one. So 1 mole of this requires 1 mole of this, as it has 3 H plus ions and 3 OH minus ions in the neutralization reaction. So Z is also 1 number of moles of aluminium hydroxide. So what is the ratio? X is to Y is to Z is equal to 1 is to 1 is to 1 based on the basicity of the given acid, that many number of moles were required. Okay, is it clear? Let us go for the next one. Yeah, equal volumes of 1 molar each of KMnO4 and K2Cr2O7 are used to oxidize Fe plus 2 solution in acidic medium. The amount of iron oxidized will be, so more with KMnO4 or more with K2Cr2O7, equal with both oxidizing agents cannot be determined. See here, whenever 1 molar of each solution, if you take KMnO4, Fe plus 2 in acidic medium, it will convert to Mn plus 2 and Fe plus 3. Okay, see here, in KMnO4 manganese oxidation state is plus 7, in Mn plus 2 it was changed to Mn plus 2 in acidic medium, as we know, change is 5 units. Here iron change is 1 unit. For balancing the reaction, we can multiply it with 5. So here 5 and here 5. Okay, so 1 molar solution can produce 5 molar Fe plus 3 according to the reaction. And coming to K2Cr2O7, K2Cr2O7 plus Fe plus 2 gives rise to, it will be converted to Cr plus 3 and Fe plus 2 is converted to Fe plus 3. Okay. Now here plus 6 oxidation state and change is 6 units, here 1 unit. Now by multiplying with 6 I will get 6Fe plus 3. So 1 molar solution, 1 molar K2Cr2O7 produces 6 molar of Fe plus 3. So in which case the content of Fe plus 3 is more means when it is treated with 1 molar of K2Cr2O7, here KMnO4 forms only 5 molar Fe plus 3, here 6 molar Fe plus 3. So in case of potassium dichromate the amount of iron plus 3 is more. Okay. So among the given, option B is the correct one. Okay. Let us go for the next one. Yeah, hydroxylamine NH2OH reduces iron according to the following reaction. So here iron is in plus 3 oxidation state in reactants and in products it is plus 2. Okay. Yes. Which statement is correct? N factor for hydroxylamine is 1. Now here in hydroxylamine if you want to find NH2OH, so X plus 3 minus 2 is equal to 0. How it is possible? 3 hydrogens are there, each one is plus 1. 1 oxygen is there, minus 2. And let the oxidation number of nitrogen is X. So X plus 1 is equal to 0, X is equal to minus 1. Okay. Now here in N2 oxidation number of nitrogen is 0. Okay. So from 1 mole NH2OH, if it converts to N2, the change in oxidation number is 1 unit. So N factor for hydroxylamine is 1. And equivalent weight of Fe2SO4 taken thrice is, yes, see here, plus 3 to plus 2, totally 2 moles. 2 iron atoms, each iron atom change of oxidation number is 1 unit. Okay, so it is also correct. Now 6 milliequivalents of Fe2SO4 is contained in 3 millimoles of ferric sulfate. 3 milliequivalents of Fe2SO4 taken thrice is contained in 3 millimoles of ferric sulfate. Okay, so here milli equivalent should be calculated by using N factor into millimoles. Millimoles. So here he has given 3 millimoles. Okay, so N factor is how much here? 2. So 2 into 3. So this is also correct. So the correct option is all the correct. Okay. So here nitrogen oxidation number minus 1 to 0, 1 unit only can change. So N factor for hydroxylamine is 1 and equivalent weight of iron N factor is 2, because here 2 atoms are there, change is 1 unit from Fe2SO4 taken thrice to FeSO4. So all the options are correct. Let us go for the next one. Yeah, statement based question. In this type of questions, we can choose the correct option A, B, C, D. When 1 is true statement, 2 is true, and statement 2 is a correct explanation for statement 1. So for that purpose, we can take option A. Option B, 1 is true and statement 2 is true. Statement 2 is not a correct explanation. Both are correct, but statement 1 2 is the not correct explanation of statement 1, then we go for the option 2. Similarly, C, statement 1 is true, statement 2 is false. Then we go for C. Option D, statement 1 is false, statement 2 is true. Then we go for option B. Okay? Right. Let us see here. Statement 1. Equivalent weight of species can be written as a molecular weight of the species divided by valence factor. Okay, right. Equivalent, definitely molecular weight of the substance by n factor, valency factor is correct, because valency factor represents valence in element, acidity, in basicity, in its acids, and total charge on cation or anion in an ionic compound. Okay, but statement 2 is correct because he has given what is a valency factor, means n factor. He has given the definition for that. But it is not the correct explanation. Why we are going to take that n factor? Why we divide with that n factor for getting equivalent weight? So what option we have to take? Both statement 1 and 2 are correct, but statement 2 is not the correct explanation of 1. So I go for option B. Option B is the correct one. Okay, let us go for the next one. Yeah, H3PO3 is a dibasic acid and its salt Na3PO3 does not exist, because being a dibasic nature only 2 H are replaceable. Yes, here state 1 is true. H3PO3, see the structure of H3PO3, it has only 2 OH groups, double bond. So basicity is 2. Basicity is equal to 2. Okay, H3PO3 dibasic acid and its salt Na3PO3 does not exist, because being a dibasic nature only 2. So whenever this H3PO3 is treated with NaOH, okay, when 2 moles of, because basicity is 2 only 2 hydroxyl groups are there here. So it can form Na2HPO3 plus 2 moles of water. Okay, this is the salt can be formed by the H3PO3, but not Na3. So here statement 1 is correct and statement 2 is a correct explanation of that one. So I go for the option A. Okay, very good. Let us go for the next one. Next, consider the following reaction: Cn taken twice, not here, Cn taken twice. Cn minus plus CnO. The correct statements about the reaction. It is a disproportionation reaction. See here, what is that Cn taken twice means? C triple bond N, C triple bond N. This is one. Okay, so now here the oxidation number of carbon is 2x minus 6 is equal to 0, 2x is equal to 6, x is equal to plus 3. Here plus 3 is there. Okay, here plus 3. And in Cn minus, so same, it is plus 3. Cn minus, x minus 3 is equal to minus 1, x is equal to plus 2. Here it is plus 2. Okay, in CnO minus, so here let it be carbon oxidation number is x, minus 3, minus 2 is equal to minus 1, x minus 5 is equal to minus 1, so x is equal to plus 4. Here it is plus 4. So what happened? Carbon oxidation state is from here to here, oxidation number decreases, means reduction. This is reduction. Okay, from here to here oxidation number increases, that is oxidation. Here if we observe, same element undergoes both oxidation and reduction. So it is a disproportionation reaction, and oxidation state of carbon changes from +3 to +2 and +4. That is also correct. Okay, +2, +3 to +2 and +4. Oxidation state of nitrogen does not change. Oxidation state of nitrogen also does not change. It is -3 in both reactants and products. It is auto redox reaction. Okay, so here it is an auto redox reaction, means no need to react with any other substance. The substance itself undergoes reduction. So it is an auto reduction reaction. So it is also correct. All the 4 options are correct. Let us go for the next one. Yeah, here again statement based question. Yeah, H3BO3 is a monobasic Lewis acid, but its salt Na3BO3 exists. Yes, salt was exist. And see here, H3BO3 is not a tribasic acid. Only H3BO3 when dissolved in water by forming BOH taken 4 times minus plus H plus. So by reacting with water due to the formation of this, 1 H plus was released. So definitely it is a monobasic acid, not a tribasic acid. These hydrogens are not replaceable in H3BO3. Only due to the reaction with water, from water itself it can be able to release 1 H plus ion by reacting with water and formation of this compound. And Na3BO3 exists, but it is not directly formed. So statement 1 is correct. Here H3BO3 react with NaOH to give Na3BO3, but H3BO3 when it react with H3BO3, when it react with NaOH, the compound formed is NaBOH taken 4 times. This is the compound formed when H3BO3 react with NaOH. But how Na3BO3 is formed actually? See here, whenever H3BO3 is treated with ethyl alcohol C2H5OH, then it can form C2H5 taken 3 times BO3. If you take 3 moles of, and 3 water molecules are liberated. Whenever this triethyl borate C2H5 taken 3 times BO3 treated with NaOH, it can now forms 3 moles of NaOH, Na3BO3 plus 3 moles of ethyl alcohol, C2H5OH. This is the indirect reaction for the formation of Na3BO3. Does not form Na3BO3 when directly H3BO3 react with NaOH. So statement 2 is wrong. Okay, now which option is correct? 1 is true, statement yes, statement 1 is true, statement 2 is false. So option C is the correct one. Okay, let us go for the next one. Yeah, yes, when a mixture of Cu2S and CuS is titrated with aluminium permanganate in acidic medium, the oxidation products of Cu2S and CuS are, okay, when Cu2S undergoes oxidation, it forms Cu plus 2 plus SO2, and similarly CuS also by treating with that aluminium permanganate, it also forms Cu plus 2 and SO2. See, what is the oxidation number of copper in Cu2S? Plus 1. Okay, cuprous sulfide, this is cupric sulfide. So change from here to here 1 unit, and here S oxidation state is -2 and here +4. What is the change here? From here to here -2, 6 units can change. So the total change is 7. N factor is 7 for this. N factor is 7. Okay. Now same here, +2 to +2, there is no change, but -2 to +4, here 6, change is 6 units. Okay, totally here 2 carbon atoms, 2 copper atoms are there. So regarding copper, we can multiply it with 2, so 6 plus 2, total change 8 here, because 2 copper atoms are there. Here only 6, okay, yes. So in aluminum permanganate, aluminum MnO4 taken 3 times, in acidic medium that definitely converted to Mn plus 2. Here 3 manganese ions are there, each one is changed 5, here also 3 Mn plus 2. So totally change is 15 units. So N factor for that is equal to 15. Based on that, I am going to check whether the given statements are right or wrong. Okay, equivalent weight of Cu to S. Equivalent weight of Cu to S. What is the equivalent weight here? N factor is 8. So molecular weight M1 by 8. So A is the correct one. Equivalent weight of CuS. CuS, what is the N factor Cu to S? N factor is 6. So this is the wrong statement. And equivalent weight of aluminium permanganate. What is the N factor for aluminium permanganate? 15. So it is also wrong. So equivalent weight of aluminium permanganate is M3 by 15. So N factor is 15. So this is correct. So among the given options, A, D are correct options. A, D are correct. So one or more than one correct option questions. Model this is okay. Let us go for the next one. Yeah. When FeS2 is oxidized with sufficient O2, then its oxidation product is found to be Fe2O3 and SO2. See here, when FeS2 is oxidized with sufficient oxygen, it will convert it to Fe2O3 plus SO2. Very good. If the molecular weight of FeS2, Fe2O3 and SO2 are M, Ma and Mc, then which of the following statements are correct? Right. Now, equivalent weight of FeS2 is, so the total change in oxidation number we have to take here. Okay. Now here iron is present in +2. It is in +2 oxidation. Sulfide. Okay. So what is the oxidation number? Ferrous sulfide can be converted to ferric oxide. So here change +3. And sulfur oxidation number is here -1 from that, and here it is +4. So change with respect to iron is 1 unit. Sulfur is -1 to +4 means -1 to 0, and +4, that is 5 units. But we have 2 sulfur atoms. Total change is 2. So N factor for FeS2 is equal to 10 plus 1, 11. So equivalent weight is equal to molecular weight M by 11. So A is correct. The molar ratio of FeS2 to O2 is 4:11. So whenever FeS2 treated with O2, it can form Fe2O3 plus SO2. Okay. For balancing this reaction, we have to take 2 moles of SO2 here, and 3, 4, 7 oxygens. Here we have to take 2 moles because Fe2O3 is formed 4 sulfur atoms. So here we have to take 4. 8, 11, 11 by 2. Okay, right. So the molar ratio of FeS to O2. FeS2, if you take 2 moles, it will be 11 by 2. Then I can write 4:11. Okay, after balancing the reaction. So this is also correct. The molar ratio of FeS2 to O2 is 11:4 is wrong because it is 4:11. So it is wrong. The molar ratio of FeTO and SO2 is 1:4. Yeah, how many moles? 1:4 moles are formed. So this is also right according to the balance equation. We can balance this equation by using also oxidation number method or ion electron method. No problem. Let us go for the next one. Yeah, for the reaction H3PO4 plus calcium hydroxide gives rise to calcium CaHPO4 plus 2H2O. Okay. So 1 mole of H3PO4 required 1 mole of calcium hydroxide and forms calcium hydrogen phosphate and 2 moles of water. Then which of the following statement are correct? See, H3PO4 basically is 3. It can able to donate 3 H plus ions. The equivalent weight of H3PO4 is 49. Yes. But from H3PO4 plus calcium hydroxide to calcium HPO4 plus 2 moles of water, only 2 hydrogens are replaced here. Only 2. So M factor is 2. So equivalent weight is equal to molecular weight divided by 2. So what is the equivalent weight of H3PO4? Molecular weight is 98. In fact, this 2, that is 49. Okay, so the equivalent weight of H3PO4 is 49 in this reaction because only 2 hydrogens are replaced, and this is called etheric salt. The resulting solution is neutralized by 1 mole of KOH. Yes, what is the resultant solution? Calcium hydrogen phosphate, still 1 hydrogen is there, so it requires KOH. Yes, it can form CaKPO4 plus H2O. Okay, 1 hydrogen replaceable here. So 1 mole of this required, only 1 mole of KOH. Okay, so B is also correct. Now 1 mole of H3PO3 is completely neutralized by 1.5 moles of calcium hydroxide. But here 1 mole H3PO4 plus calcium hydroxide, then if it forms calcium Ca3PO4 taken 2 times plus here 3 hydrogens are there. Okay, now how many? Yes, H2O. See here, after balancing 3 calcium and 2 are required, so 6 water molecules are formed. So for 2 moles, 3 moles of it was required. For 1 mole, how many moles were required? 1.5 mole was sufficient for the complete neutralization of 1 mole of H3PO4, because for 2 moles, how many moles of calcium hydroxide was required? 3 moles. So C is also correct. Now 1 mole of H3PO3 can be neutralized completely by 1 mole of calcium hydroxide, but that is wrong because 1 mole of this requires 1.5 mole. So this is wrong. So answer for this question, multiple answer question, is A comma B comma C. Okay, let us go for the next one. Yeah, when an equimolar mixture of Cu2S and CuS is titrated with barium manganate in acidic medium, the final products contain Cu2 plus, SO2 and Mn2 plus. If the molecular mass of Cu2S, CuS and barium manganate is M1, M2 and M3 respectively, then equivalent mass of Cu2S is, yes, in the previous case also we studied that Cu2S can be converted to Cu plus 2 plus SO2. Here change in oxidation number with respect to this is 1. We have 2 copper atoms in Cu2S, so total change is 2, and S is having -1. Here and here plus 4, the total change is 5. Okay, sorry, here minus 2 to plus 4, total change is 6. So n factor here is 8. Yes, equivalent mass of CUT is m1 by 8. Correct one. Next, equivalent mass of CUS is m2 by 6. CUS. Okay, here this is plus 2 and this is minus 2. It will convert it to plus 2 to SO2, same plus 4. With respect to copper, there is no change. With respect to sulfur, 6 units change. So, B is also correct. Equivalent mass of barium manganate is, here barium manganate means MnO4 minus can be converted to Mn plus 2. From plus 7 to plus 2, so here n factor is equal to 5. But in barium permanganate, we have 2 permanganate ions. So the total change is 10. Total barium permanganate. So this is not correct. Cu2s and Cus both have same equivalents in mixture. Okay, same equivalents in mixture. But number of equivalents is same. D is also correct. Let us go for the next one. Yeah. Which is our incorrect statements? Equivalent mass of H2PO3 is 40.5. But H2PO3 is an ion individually. We can take the total charge 1. So H2PO3 equivalent mass should be n factor is equal to 1. So here 2 plus 31 plus 48, that is equal to 81 by 1 only. Equivalent weight of H2PO3 minus. So that is wrong. 62 is wrong. So incorrect statements as is asking here. Equivalent mass of H2PO4 minus may be equal to molar mass or less than molar mass because it depends on the reaction. Okay. So that depends upon the reaction. How many H plus ions can be replaceable? So it is a right one. KMnO4 has maximum equivalent mass in acidic medium. But KMnO4 in acidic medium, n factor for KMnO4 in acidic medium, n factor is equal to 5. So equivalent weight is equal to molecular weight by 5. In acidic medium, molecular weight by 1. In alkaline medium, molecular weight by 3. In neutral medium. So equivalent weight is maximum in alkaline medium because it is just m by 1. So it is also wrong statement. Now oxidation state of hydrogen in MgH2 is greater than in H2O2. Here metal hydride, in metal hydride hydrogen is having oxidation number -1, and here in peroxides or whatever more electronegative element is attached +1. So oxidation state of hydrogen in MgH2 is less than that of the oxidation number of hydrogen in H2O2. Okay, so this is also wrong. So answer, incorrect statements he has asked. So what are the answer? A, C, D. A, C, D. Okay, let us go for the next one. Yeah. Column 1, equivalent mass is equal to molecular mass by 33. Okay, now see here. FeS, I am taking this, FeSCN taken twice, FeSCN taken twice can be oxidized to Fe plus 3 plus SO4 minus 2 plus CO3 minus 2 plus NO3 minus. Okay, we can take change here. Fe is in +2 oxidation state. SCN taken twice here, plus SCN minus. So from here to total we can change here, plus 6 plus 4 here plus 5. The total change in oxidation number, if you find, that is equal to 33. So for option A, molecular weight by 33 is for this one. Okay, for A, Q is correct, because n factor is 33 if you calculate the total change. And then for B, equivalent mass is equal to molecular mass by 27. Okay, so in which of the following that was correct, we will check it. Okay, when CrI3 is converting into, yes, CrI3, Cr2O7 minus 2. So here in CrI3 it is plus 3, it is minus 1, and here it is plus 6, and here IO4 minus x minus 8 is equal to, so plus 7. So the total change from here to here, 3 units, from here to here 8, plus 3 iodines are there, 3, that is equal to 24. 24 plus 3, 27. So n factor in this reaction is equal to 27. So for B, it is P is correct one. Okay. Now coming to C. So I am going to this As2S3 oxidized into ASO3. See here, As2S3 means arsenic plus 3, sulfide minus 2. Here ASO3 is X minus 6 plus 5, SO4 plus 6. What is the change here? Arsenic change is 2 units, but 2 arsenic atom, total change 4. And here for sulfur, minus 2 to plus 6, it is 8, 3 sulfurs are there, so 8 into 3, 24. 24 plus 4, 28. So n factor is 28. So for C, S is the correct one. Okay. Now for D, I am going to R, ammonium thiocyanide oxidized into. So the remaining part was R. For D it is R if you are going to choose. Okay. So for A, Q is right answer. For B, P is right answer. For C, S is right answer. For D, R is the right answer. Matching type question. Okay. Yes. This is the end of the session. Thank you so much.